This is Physics Medicine Online Tutorial class organized by Mrs. Okuma I. Here we bring physics at your doorposts. Distance is never a barrier. Now today we want to look at solar collectors. We look at solar collectors. Now we look at our specific objectives. By the end of the lesson, students will be able to, number one, define solar energy. Secondly, define solar collectors. 3. Itemize the component parts of a flat plate collector. And finally, explain the principle of operation of solar collectors. Now, once you hear the word solar, what comes to your mind? Sun comes to your mind. Now, you find out that a country, Nigeria, has an enormous sun or sunlight. And in such a country with other countries, you find out that this sun or energy from this sun can be harnessed or can be harvested for an important things. And that is what we want to look at today. Solar collector. How do we collect the energy from the sun? And what do we use it for? Now, the sun is an enormous energy source. And this energy released from the sun, we call it the solar what? Energy. Energy from the sun is called the solar energy. Though this energy is plentiful, it is however thinly distributed over a large area, and it must be harvested or collected using what? Solar what? Collector. So that is what we are talking about today. This energy from the sun, we have to harvest it using what we call the solar collectors. Now we look at production of solar energy. Production of solar energy. Now the sun is a vast ball of hot glowing gas. When you look up to the sun, it looks like a ball and is very, very hot. The temperature at the core of the sun is as high as about 15 million degrees centigrade. Million, that is 15 times 10 raised to the power 6 degrees centigrade. That is the temperature at the core of the sun, the inner part of the sun. But at the surface, the one we are seeing, the temperature is about 6,000 degrees centigrade, which is a very high temperature. A huge amount of energy is produced in the sun by the process of nuclear fission. Using the process of nuclear fusion, we produce a huge amount of what? Energy from the sun. Nuclear fusion, that is a process where two hydrogen isotopes or two hydrogen nuclei, they combine to form helium and neutrons, and therefore they will release a huge amount of what? Energy. Now the very high temperature at the core of this sun, which we say is around 15 million degrees Celsius, that is what makes this nuclear fusion process to be what? Possible. Now, through this process, the sun released into space an estimated energy of about 4 times 10 raised to the power 20 joules per second. Can you see the energy that is released from the sun after the process of nuclear fission? A very high energy. In a second, the energy that is released from the sun is around 4 times 10 raised to the power 20 joules. Uncountable, very high. This energy is released principally in the form of what? Light and heat. So this energy from the sun is released in form of light energy and also in form of heat energy. In most areas of the world, solar energy is collected using large concave mirror and concentrated on water to produce what? Steam that drives steam what? Turbine. So in some part of the world, you find out that this solar energy is being harvested using a concave mirror, and this concave mirror will be concentrated in the water, and when they are concentrated in the water, they will be able to drive steam that produce, they will be able to drive steam turbine. So with this you can equally generate electricity using this solar energy. Now some are also collected by solar panel or roofs of houses for domestic heating purposes, and this is the one we are going to look at now. So this one we can use for domestic purposes, for heating water and other things in our house. Then remember the other one, we say you can use it, concentrate the mirror in water, the water can drive the turbine, produces steam, the steam that drives the turbine, which can equally generate what? Electricity. Now let's see the diagram of this solar collector or the solar panel. Look at this. Look at the solar panel. Look at this. They can mount it on top of the building, on top of the roof, and it will collect it. We collect the energy from the sun, which we can use for a lot of things. So from the diagram we have seen it. These are the panels, solar panels, the solar collector. You can see the color, they are darkened in color to make it to be a good absorber of heat. You can see the color, they are darkened in color. You have a special color to be able to absorb the heat from the sun. Now, so this is the solar collector or the solar panel. This is the real label diagram. Here, these are the rays of light. You mount this on top of the house. You can see the rays of light from the sun. Then you can see this one, we can use it to heat water. We can use it to heat water in the lab or in our different homes or in a big laundry industries. Now these are the flat metal plates. Look at these two things. They are the flat metal plates. Now this is a flow tube. You are going to see their functions. These are the flow tubes. This is the outlet where water goes out. Then the inlet where water comes in. Then the water will be heated up here in the metal plates. Now here you have the insulators and others. So a flat plate collector, as we have seen in our diagram, is a shallow metal box that is typically mounted on a roof or a high stand that heats water using solar energy. So that is the flat plate collector. You mount it on top of the roof to be able to heat the water. Now we say a flat plate collector is a large shallow metal box typically mounted on a roof or a high stand that heats water using solar energy. The flat plate collector is usually designed to operate in the low temperature range, starting from ambient or surrounding temperature to about 65 degrees Celsius, or in the minimum temperature range from ambient to 100 degrees Celsius. So this flat plate collector, it is designed in such a way that it can use a low temperature, surrounding temperature, as low as the temperature is. You can use it. It can collect any amount of any temperature of the sun up to 65 degrees Celsius or even up to 100 degrees Celsius. So such flat plates, they are designed to have heat delivered at low cost for a long period. So they will deliver heat at low cost but in a longer period. Now A flat plate collector consists of, number one, a metal flat plate, which I've shown you in the diagram. A metal flat plate that receives the shortwave solar radiation and in turn absorbs it. So this metal flat plate, we call it the absorber plate. They are usually made of what? Good conductors of heat, like copper or aluminium. Now let's see it again in the diagram. So look at this. This is the flat metal plate. A metal plate that receives the shortwave solar radiation and it will absorb it. So look at this plate. Look at it, this, and look at it, this. You can see it from the labeling. So these plates now, they are flat. They are the flat metal plates, or you call them the absorber plates. So they are made of good conductors, like your copper or what? Your aluminium. So they receive the shortwave solar radiation, and when they receive it, they will absorb it. So this radiation from the sun in form of rays, they will do what? They will receive them, and they will do what? Absorb it. Now the next one is the tubes or channel or passages that are attached to the absorber plate. So look at the diagram. These are the tubes or the channels. So you can see the labeling, flow tubes. This is where they go out, they come in, the inlet, the water comes in from here. When it has been heated, it goes out from here as a hot water. So the tubes or the channels or passages that are attached to the absorber plate that helps to circulate the liquid, example water, that removes the thermal energy from the plate. So it helps to circulate this liquid and remove the thermal energy from the plate. Now the next one is the thermal insulation. The thermal what? Insulation. What is the work? That is usually provided at the back as well as the side of the absorber plate to minimize heat loss. So this thermal insulation, they minimizes heat loss. Let's look at the diagram. You can see it at the back. The thermal insulation is at the back or as well as the side of the absorber plate. Remember, this is the absorber plate. Now this is the thermal insulation. You can see it at the back of this absorber plate. You can see the labeling insulation, or you can see it by the side of this absorber plate. And what is their work? They minimize what? Heat loss. So it's an insulator. It will prevent heat loss. Then the next one is a transparent cover. A transparent cover, which we call glazing, is on top, and this cover top is made of glass or papless or transparent plastic. What is the purpose of this transparent cover? Let's see it from the diagram before we talk about the purpose. Let's see it from the diagram. So the transparent cover, we say we find it at the top, is made of glass. Look at the transparent cover. You can see from the diagram the glass. So this cover is made of what? Glass. Is made of what? Glass or transparent plastic. Now what is the purpose of this transparent cover? The function or the work of the transparent cover, number one, is to reduce the heat loss in the upward direction. Remember, it's a plastic, it's an insulator, so it will minimize heat loss in the upward direction, usually associated with the absorber plate. And number 2, to allow for maximum solar energy. Since it's transparent, energy from the sun can pass through it. Rays of light from the sun passes through it and gets to the absorber plate. So it allows for maximum solar energy transmission to the metal plate. And the next one, finally, it can be asked in the exam or WAEC. What state 3 functions of this transparent cover, or called the glazing cover or top? The third one is to shield the absorber plate from direct exposure to weathering. So as you can see from the diagram, since it is made of glass, it will shield this absorber plate from direct, look at the absorber plate, it will shield it from direct exposure from weathering. So these are the functions of the words absorber plate or the glazing. Now these components we have listed, they are enclosed in a metal box with a dark colored absorber plate on the bottom. The sides and bottom of the collector are usually insulated to minimize heat loss. So all these things are inside a box that is dark colored. You now mount it on top of your roof. Now we look at the principle of operation of this flat plate collector. What is the principle of operation? How does it operate? Already we have explained that, because we have explained the component parts. So in summary, the metal sheet is exposed to solar radiation. You mount it on top of the building where it can get heat from the sun. Now sunlight passes through the glaze cover. Remember, the glaze cover is made of glass or plastic, transparent material, so that sunlight can pass through it. So when sunlight passes through this glaze cover, it strikes the absorber metal plate. Remember, the absorber metal plate is made of conductor, copper or aluminium. Now the plate heats up, changing, because is a good conductor, it will be heated up. Now changing the absorbed solar energy into what? Heat or thermal energy. Now the absorber plates are commonly painted with selective coating, as we have seen in the diagram, to absorb and retain heat better than ordinary black paint. I showed you that in that diagram. You can see the selective color that is not really black, a color that can usually absorb heat from the sun. So that is a selective color. Now we say that the temperature of the absorber plate rises until at the equilibrium temperature, that is the rate at which energy is received from the sun, equals the rate at which heat is lost from the plate. So we find out that this temperature of the absorber plate will rise until at equilibrium, until we obtain what we call equilibrium temperature. And what do we mean by this equilibrium temperature? It is the rate, temperature at which the rate of the energy received from the sun will be equal to the rate at which energy is lost from the absorber wall plate. Now by soldering metal pipes, the plate is converted into heat wall collector. So you now solder the metal pipes we have seen there, the channel through which water passes. So by soldering the metal pipe, the plate is converted into what? A heat wall collector. So the heat in the metal collector will be transferred to the liquid. So the heat from the metal collector from that absorber plate will now be transferred into that liquid inside the pipe. Remember, the pipe is inside the metal plates. Now the heat in the metal collector is then transferred to the liquid, passing through the pipes attached to the absorber plates. The heated liquid is transferred to a tank for storage and their use. So we have seen that in our diagram. The heated liquid will now be transferred to a tank for storage, which you can use it in your laundry, you can use it in a big laundry industry, you can use it in a big cafeteria or restaurant, in a big family house. It can be used where hot water is needed in large supply. So look at the heated water that passes through the pipe. It can now be stored in your storage tank for use. So that is the principle of operation of this flat plate collector, which we call the solar collector. Now we go over to evaluation question number 1. Define solar energy. 2. What is solar collector? 3. Itemize the component parts of flat plate collector. We have mentioned the component part of it. Finally, explain the principle of operation of a solar collector. We have come to the end of our today's lesson. Thank you for your patient listening. See you in our next class. I remain your teacher, Mrs. Okuma.